So in the large graph, I have shown you that you have to you have to draw this line, and then you have to assume some point. You have to project this point. You have to project this line, and the line for which you'll be getting this intersection like this. That will be your x1 and y1. And now suppose you have to do certain trial and error. Now finally, after getting an exact x1 and y1, what you have to do is see, this is the formula. What you have to do exactly is that uh, now after getting the x1 and y1, suppose I have given that from graph we got x1 as 0.258 and y1 as 0.117, right? Now our ultimate goal is to find the e1, the e2 and the e3, and these are three, right? So for in order to calculate this e1, the formula is given as x m into xm minus x1 upon y1 minus x1. This is we have derived earlier, right? Now we know m, we know xm1, we don't know x1, right? And we don't know y1 and x1. So this x1 and y1 we have to get from the graph, and this is why we brought the graph. Now we got the m as 140 in the last class. M is equal to 100 plus 40, right? So 140, we'll substitute m as 140 here. Xm we got as 0.217. This is from the theoretical calculation itself. 0.217. X1 0.25, this we got from the graph by the trial and error. Y1 similarly we got from the graph, and x1 as this. So you will get as e is equal to e1 as 43.6, right? Now we know that from the mass balance initially itself that m is equal to e1 plus r1, right? Now m is 140, even you got as 43.6. You can get it, you can get r1 as 96.4 kg, right? Now this r1, right, this r1, as you can see from the graph, this r1 is a feed for the stage 2. So similarly, like f plus s is equal to m, r1 plus s is equal to m. F has been placed by the f because r1 is a feed for the stage 2. We'll substitute r, which we got as 96.4 kg. Okay, m, s is our solvent 40 kg. It is same for all the stages. So m you will get as 136.4 kg. Now again metal balance same as like this, f into xf plus s into ys is equal to m into x1. Similarly here, in the place of f we are writing r1, and in the place of xf we are writing x1. S into y is equal to m into x1. R1 we got as 96.4, x1 2.58, which we got as from the graph. This is 0, m is 136.4, and xm2. We have to calculate xm2. So what we're doing is, again similarly the same process continue. You will be having a line. Now see, as I said, suppose you got this r1, right? This is r1. You have to draw a line. You have to draw a line which will be connecting this b0. Whatever the xm2 you're getting, suppose I got as 0.2, I will take 0.2 xm2 here. I will straight away forward and I will extend up to this point. This is my m. Similarly, I will assume some x1 and y1. X1 I will assume. I will project this. I will see this. Again I will see this, and I will see whether it is touching this line. If it is touching, then x2 and y2, whatever I have assumed, that is right. So suppose I got this x2 and y2 as from graph 0.227 and point y2 as 0.995. I will calculate e2 as m2 into xm2 minus x2 minus y2 minus. I got x2 and y2 from the graph. I'll substitute all the values. I will get the e2 from r. Again from I'll get e3 m minus e2. I'll get as r3. Now this r3, this r2 will be the stage for the feed for the third stage. R2 is equivalent to, I'll get m3. This is m3. Similarly, I will get xm2. I will plot a graph. I plot a graph again. Whatever the r2 I got, I will join this same r2 to 0. Again I'll assume a point. I'll see this. I'll project and I'll get the finally. So I'll repeat the process till once I get e3. So final extract will be e1 plus e2 plus e3. E1 46.3, 46.3, 45.6. This is my total extract, and refinite is 83.44. Thank you. This is what our ultimate goal was.